CentreDP2. This is a 3-minute talk about a new project. So this project has only been running for a little bit under 6 months. This project is, in fact, I can skip straight over this. This project is coming out of the initiative to look at resource efficiency. That was the call that was opened last year, and the decisions were made on the projects in the summer. Fundamentally, what we are interested in doing in this project is looking at resource efficiency questions in production of specialty long products. Now, there are a lot of unusual small volume long products produced in Sweden which are not particularly easy to make. And I'll show you an example of what I'm talking about in a moment. Fundamentally, what we would like to do is understand more about what is really limiting ability to produce center defect-free material. And some of this actually comes back to Patrick Erland's question a little bit before about segregation and the effects of segregation in rolling. But what we really want to look at here is what characteristics of the material and the process are really limiting how we can produce these materials today, what we could do to modify those to try and improve the situation, on the basis that doing so will make these a lot more efficient to make, both from a resource efficiency point of view, productivity and cost. This project is in fact a continuation of a pre-study project that was run inside the SIO for metallic materials in 2014 and 2015 called CentreDP, which looked at a range of, I guess, pre-study questions which led to the specific focuses in this project. To give you a concrete idea of what I'm talking about here, This is an example from the project consortium, how an iron-based superalloy is made today in rods. So it's steel is made, it's continuously cast to a billet. Billets are welded together to make feedstock for vacuum arc remelting, which is then cast to an ingot, which is then rolled to a billet, which is then rolled to a rod. So there is a double remelting process in here. This is very low productivity, it's extremely expensive, and it's very poor yield. We wonder whether we could do this, which is simply take that intermediate step out. Of course, what we need to understand is what's going on inside the material. We're talking about center defects. In this particular case, the final material is 5 to 8 millimeters in diameter, so it's had 95% cross-section reduction. So it's not a matter of simply closing the casting defects. It's that center segregation and features of the cast microstructure have limited hot ductility, and that limits how we can roll them. And the only way that the producer knows how to do that is by this very exotic route. And the question is, could we do something related to heat treatment to modify the specific features of the microstructures which are limiting the way that they roll, and do something in order to be able to produce that. Now, we're not going to claim that this material will be as good as this material, but it'll be much less expensive, and it will be able to be produced in much higher volumes than today. And that's another problem. Many of these routes have very, very limited productivity, which has a lot of impacts on customers, on the amount of material they can buy. This particular material, I think, is very popular in the 787 Dreamliner, and there are actually absolute limits on how much can be produced in Sweden because of that. The estimate is that if we could do this, we might have something that would have about a 30% better yield and about a 50% reduction in cost, which is a fairly major change in the way we produce these materials. So what will we do? And I've talked a little bit about some of the key things that we'll do, but most importantly, I think we try and understand what it actually is in cast microstructures which limits their ability to be rolled to rods and bars with a degree of center soundness that makes them useful for end customers. And that means, amongst other things, understanding what the safe material processing parameters are and how some of the mechanisms, such as deformation, pore closure, pressure welding, the things that modify the internal structure of the cast material as it's hot worked. Similarly, we'll look quite a lot at optimization and design of roll passes, and Biesh talked about a tool to do that in the OptiRoll project, and some of that code will in fact be used in this project to understand more about how we can change the way rolling can be done on existing plants in order to improve their behavior. We have four rolling mills will be involved in these trials and 2 steelmaking plants. There'll be 3 materials in total. I think something like a super austenitic stainless steel, a super alloy, and a very high hardenability quench and tempered steel for mining applications. Another thing that we'll also do in this project is we intend to have 2 open workshops or conference meetings, one in the midterm and one in the final workshop, because we've had contact from a number of companies who are active in Jönköping who are not part of this project who would like to learn more about what we've been doing with this. So who are we? Very quickly, the project itself is started last year, will finish in 2019. KTH Material Science, Sria Kimab and Sria Mefos are providing most of the research in conjunction with Morgans Hammar, Ovako, Sweden, Fagersta Stainless, Sandvik Material Technology and Sandvik Heating Technology. So fairly much all of the long products producers in Sweden, or almost. If you would like to know more about this, you can contact me. You can contact Ibrahim Musavi from Sandvik Material Technology, who's our project chairman, or Rachel Pedersen from the conference office. So if anyone has any questions, 3 minutes. Thank you.
Very, very good. So, if anyone has a quick question to David?
Sure, far away.
How will you evaluate that you have been successful in reducing the porosity? What methods will you apply?
Predominantly, because many of the sections are quite small, we'll probably use microscopy mostly, I think. There will also be some ultrasound, and I think in your particular case, a lot of ultrasound data from Haliforce, as I'm led to believe. So yeah, it will basically be, the idea is that there will be some test coils will be rolled in Fagersta and in Hallstahammar also, and they'll be cut up, and we'll do a lot of microscopy to see if we can actually find evidence of the sort of defects we're looking for. Because obviously rod coils, one ingot produces many thousands of meters of rod, so it's sometimes looked like looking for a needle in a haystack, but that's the plan.
Tack.